Good morning and good afternoon, everyone. Thank you for joining us today for this last webinar of the year. For us here at Severalnines, it's great to have you with us. 22nd of December, I know that a lot of people are getting ready to go on vacation, so it's really good of you to be with us today. We'll be talking about Polyglot Persistence over the next hour with my colleague Art van Scheppingen, who will be presenting. But before we get started, I just wanted to briefly run through some logistical details, just to let you know that the session is being recorded, and we will make the recording available to you after the session, of course. So we'll be publishing this via a blog post, and you can access the slides and a replay of the webinar that way as well. You can ask us questions at any moment by using your control panel. There is a chat option, but there's also a question section in your control panel. So feel free to use the question section to get in contact with us if you have any questions on the content, or if you need help with any other topics. And if you have questions following the webinar, or if you want to get in touch with us, feel free to email us at info@severalnines.com. And we'll get back to you on that channel as well. So just before I hand over to Art with the actual presentation of the day on Polyglot Persistence, I wanted to ask all of you who are participating today a quick question. Since we'll be talking about Polyglot Persistence and different types, for example, of data stores, just so we have a good idea of the participation today in the audience, how many different data stores are you currently using in your organization? That'd be really interesting to see. And I'll just give it a few seconds for everyone to participate and provide their answers here. So whether you use a combination of SQL and NoSQL, there might be 2, 4, 6, or 8 different data stores that you have in your organization that you're looking after, and it'd be great to just get your feedback here. Great, thanks very much. I'm just going to close this poll and share the results. So it seems that the vast majority of us today who are participating have 4 data stores, and minimum 2, I suppose, and 2 and 4 seem to be the numbers. Art, any comments on that before you get started?
Well, it's interesting to see that already a lot of people are using multiple data stores. Because it's getting more and more widespread to use various data stores, and 67% is already using 3 or 4 data stores, 4 or more actually. So that's a lot.
It is, yeah, it is, and it'll be interesting to see then later on what they are. So we'll have a question on that further down the webinar.
Yeah.
So thank you for this first of all, and with that, I'll hand over to you, Art.
Thank you, JJ. Okay. Are the slides visible at the moment?
Yeah, and if you go full screen, then that'll be great. Yeah.
Okay, so it's yet again. This should be it, if I'm correct.
Yep. Perfect.
Yeah. Good.
Perfect.
Okay, thank you. So the agenda for today is quite short. I'm going to explain first what Polyglot Persistence is. And once I have explained that, I'm going to illustrate that with an example project within an average company. And after that, I'm going to take you to kind of a conclusion whether Polyglot Persistence is good or bad. And in the end, we're going to show you with a short demo how to use cluster control for Polyglot Persistence within your company. And then at the end, there's the question and answer section. So if you have any questions in between, you can just ask them, and we can see if we can answer them at the end. So what is polyglot persistence? Polyglot persistence is basically using multiple specialized persistent stores, data stores, rather than using one single general purpose database. So in other words, you use more than one database. How did that happen to be in our current environment? Well, the term is actually created a couple of years ago due to the way that we are working at the moment. Everything is changing. Enterprise applications are becoming more and more complex. In the past, they used to be quite simple. An enterprise had a website and they had a separate application for, let's say, their invoices, and that wasn't shared at all. But since enterprises or any other business is integrating more and more into their websites, you need to have multiple applications tied together within one application. That also leads to separate teams working together on one single product. And most of the time nowadays, that's done in DevOps or agile style. That also means that those teams, they have to own their applications. They have to take the ownership of the applications. And as they take ownership of the applications, they also tend to use to integrate it into one single product using various languages. And that's mostly due to the way they work by creating in the backend microservices to abstract their code from the backend services behind it. So at the front end, you get a big application using one single layer, while in the back you have services providing data or information to the customer. And also all those people in those teams, they have their own preference for programming languages or storage systems. So if we go down to companies, the way they used to work only 5 to 10 years ago, if you would state that they were doing monoglot programming, that basically meant that most of those companies back in those days were only using and allowing one programming language. And the reason for doing that was really, really simple. It's saving cost. It's improving the readability of the code of the code base. So any developer within a company can work on the same code base within a company. That's saving a lot of cost. Also, the people that have to support the application and put it on the hosting side or the application side, they only have to support one single platform. So that's a lot more easy to do, and you only have to train them for one single purpose. The knowledge shared between the people is that all of them are experts on this application and on this language. So it's mostly cost saving, and it's a rationale behind it, of course, because why would you need another language if you already are supporting one of the languages? So suppose you're using Java, or back in those days, a lot of people were using Perl. Those languages were basically a jack of all trades language. They were good at certain things, but do they excel in everything? Well, that's highly doubtable. If you take that to the next level, where I make a comparison with a carpenter, does a carpenter only use one single tool? Well, obviously, the carpenter is really fond of his hammer, and he uses it a lot, and he can use it in multiple ways. He can either hammer in a nail, extract a nail with the back of the head. But in reality, they use a very broad variety of tools. And every single one of those tools is a really specialized tool. So you probably cannot use the hammer in a lot of other ways. You cannot use a hammer to screw in screws into the wall. You can hammer them in, of course, but you cannot screw them in. So hence you have a screwdriver. And also with the screwdrivers, you have various types. So you have the flathead, you have the Phillips screwdriver, and they are not compatible either. So of course, if you want to use a specific tool, it has a specific purpose. And the same goes for polyglot programming. You're using programming languages for what they're good at. And that offers you great flexibility to use a specific language where it's good at. So in this example, the Java is really good at securing APIs, while Scala, you shouldn't use that for such a purpose. It would be too slow for doing that. But it's actually really good at real-time stream processing. And Python is really good at text analysis. And if you combine everything this way, you can tie it together using, for instance, a framework like AngularJS at the front end to serve out the data to your users. The nice part of using various languages is that you no longer everyone is an expert at one language, but it's at least at one or more languages an expert. So you're spreading across languages your knowledge. And also you don't need specialized knowledge anymore on how to do, for instance, real-time stream processing in Java, because that's a really specialized piece of knowledge. It's possible, but do all your developers need that specialized knowledge? While in Scala, it's almost already built in. If you take this one step further to an abstraction layer, where we have a user visiting a website that's using microservices in this case, those microservices are being accessed via an API, and whether the microservice is the API or you have an API layer in between, that's something I abstracted away here. You can see that on the left side, it's interacting with some profile API, and profile API is using a login microservice using Java, while it's actually using a Python service at the same time to retrieve the profile details. In the middle, there's a billing API, and the billing API is going to the billing microservice that uses Go in this case. I'm not going to state whether you should implement your billing microservice in Go or not, but in this example, we wanted to give like a couple of languages that are suitable to do this. On the right side, there's the recommendation API, and the recommendation API is interacting with Scala backend service. And in this sense, you can already see that in one single company, we're using 4 different languages for what they're good at, and not only using, for instance, either a Java or Python to do everything at the same time. If we then look at the companies, the way they used to work 5 to 10 years ago, and here I go again with the 5 to 10 years ago, they all used to have one monoglot persistence. So they made a choice to support, for instance, in this example, MySQL, to store all their data. But they could have chosen any other product. They could have chosen Oracle as a standard, or they could have chosen Postgres as a standard. The thing is that 5 to 10 years ago, databases were really expensive machines. They were really huge, expensive hardware to implement. And on top of that hardware, most of the time you had to pay also a license fee. And that license fee costs a lot of money. So better standardize around one data store and one single database cluster than to have a broad variety of smaller databases. Well, 5 to 10 years ago is already a long time ago in database land, and the landscape changes. So 5 to 10 years ago, we had mostly relational data stores, but 10 years ago, key value data stores started to emerge, like Memcached. I think Membase was something like 5 years ago only, and that in the end resulted into a merge with Couchbase. Columnar data stores started to emerge as well at the same time, because the way we retrieve data from a relational data store is by retrieving rows, while in a columnar data store, you retrieve columns instead of rows. So that needed a new approach. So new data store types started to emerge, like